Hi guys, in this video we are going to evaluate this integral. It's an improper integral and it has an infinite discontinuity. First of all, I noticed that it's not a type 1 proper or improper integral because I don't have a negative infinity or an infinity here. If I'm looking at this and I'm trying to decide if it's improper or proper, I have to look at the integrand. And I have to think about when this function is defined and when it isn't defined. The easiest way to think about when it isn't or is defined is to think about when it isn't defined. We're going to have a problem if we divide by 0. We know we're not allowed to divide by 0. And if x equals 4, we would be dividing by 0. So we've got a problem at this upper limit of 4. So we can write this as the limit as b approaches 4 of the integral from 1 to b of our integrand. Everything else stays the same. I just replace the 4 with a b and I let b approach 4. Since it's the upper limit, well, we're going to approach from the right, but I want you to see why. Okay, so if I'm trying to visualize what's going on here, I know I've got an infinite discontinuity at x equals 4. So I go over 1, 2, 3, 4. And that's my line. My function is getting very close to this line. Now if x isn't 4, if this number x minus 4 is positive or negative, it doesn't matter whether it's positive or negative. If I take that number and I raise it to the 6th power, a positive times 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 a positive is a positive. And if I multiply 6 negatives together, the negatives cancel in pairs, so it's a positive. So this is a positive number in the denominator, and I've got a positive number in the numerator. So it's going to look kind of like 1 over x squared. Just shifted 4 units this way, the 3 stretches it a little, and the 6 changes the slope a little bit. But the graph is roughly going to look like 1 over x squared, just shifted. Something like that. Okay, and now we're interested in the area between 1 and 4. So this is the unbounded area we're trying to find if it's finite. And we're finding that by taking the limit as b approaches 4 of this integral instead. So this integral represents the area under the curve between 1 and b. So I'm going to let b be some number over here. I'm going to find this area, and I'm going to let b get closer and closer to 4 from, I wrote the right, but that's the left, isn't it? The upper limit's from the left. Sorry about that. I can see from my picture, I'm approaching 4 from the left. Okay, so the first thing we always do with an improper integral is we write it as a limit. We did that, that's good. Great first step. And then we just evaluate this proper integral using the Fundamental Theorem of Calculus. Okay, so I'm going to bring my limit along because I want everything to be nice and equal, but I am really focused on this integral here. I'm going to bring that x minus 4 to the 6th up to the numerator, make that negative, and now we're going to do a u sub. And remember, whenever you're doing a u sub, all of the pieces here need to be written entirely in terms of u. And u is usually the quantity that's under a radical in parentheses inside a trig function inside an exponent. It is something that's nested inside something else. So as soon as I see these parentheses around the x minus 4, I'm thinking that's probably my u. So I'm going to let u equal x minus 4 and then compute its derivative. Well, the derivative of x minus 4 is 1. So I have 1 times dx is du. So all of this can be written in terms of u. That's 3 u to the negative 6, and dx is du. So all of this can be written, that's fine, Now I just need new bounds. For the upper bound, you replace x with b, and you get u equals b minus 4. For the lower bound, you replace x with 1, and you get u equals 1 minus 4, so that's negative 3. So I have the limit as b approaches 4 from the left of this new integral. After a change of variables, my lower limit is negative 3, my upper limit is b minus 4, and this is 3 times u to the negative 6th times du. And now we just anti-differentiate, plug in the bounds, subtract, and take the limit of the result. Okay, so we're still doing the fundamental theorem of calculus part. Getting ready to do our u sub. We did our u sub. Now we have to anti-differentiate using our basic rules. So we add 1 to the exponent and then divide by the new exponent. Then you substitute in u equals negative 3, and then you substitute in u equals b minus 4 and subtract. So I'm taking out the negative 3/5 there. And that u to the negative 5, I could write that as a 1 over u to the 5th if I wanted to. I'm going to write it this way because it's easier for me to think through these limits when it's written in this form. And now we will substitute in our upper limit and lower limit and subtract by FTC. Okay. So the question is, what's the limit of that result? What happens to this quantity as b approaches negative 4 from the left? Well, that's just a constant. 3 times 3 times 3 times 3 times 3. That's 9 times 9. It's 81. 81 times 3. It's negative 243. Negative times a negative is going to be positive. You don't have to do the arithmetic in your head. You're in calculus. I'm sure you can do it if you want to, but you don't have to. You could use your scientific calculator for that. Now we've got to take this limit. Okay, so what happens to this guy as b approaches 4 from the left? Notice if I plug in 4, I've got 1 divided by 0. It's been a while since Calc 1. If you have if you have a non-zero constant divided by 0, that tells you you're going to get either plus or minus infinity out of that. To figure out which one it is, you need to figure out what the sign is of all the factors involved. The 1 in the numerator is obviously positive. I have to think about the sign of b minus 4 all raised to the 5th as b approaches 4 from the left. And my picture would really help me here. As b approaches 4 from the left, I'm looking at values of b that are slightly less than 4, like 3.999. So if I take b and I replace it with 3.999, 3.999 minus 4 is negative. If I take a negative number and I raise it to the 5th, it's still negative. So what I end up with here is a positive number divided by a tiny negative number. Positive over a negative is a negative, so that's going to go to negative infinity. So this guy goes to negative infinity, but then we multiply it by a negative 3/5. So the negative times the negative gives us a positive. So the final limit is positive infinity. So what does that tell us? This integral from 1 to 4 of 3 over x minus 4 to the 6th dx, it's an improper integral and it diverges. It diverges in a special way. It diverges to infinity. Now, what does that mean? It means this area up here, this area that we were trying to calculate, is like infinite area. as b gets closer and closer to 4, we're adding something that's just getting larger and larger and larger. Because this is getting very, very large, and then I'm multiplying that negative by a negative, and I'm getting a positive number. So I'm getting a very large positive number plus this guy, and so the whole thing goes to infinity. As we get closer to 4, yeah, the area under that graph approaches infinity. So 3 steps to evaluating an improper integral. We're still doing the same 3 steps as before. We write it as a limit, and that we do that by identifying the problem x value on that interval and letting a or b approach that problem x value if it's either the lower limit or the upper limit, or we write it as 2 integrals and then do that for both of them. Then after you've got it written this way, you almost ignore the limit for a while and you just evaluate this guy. You just want to know what's the area from 1 to b. And we had to use u sub, and we plug in b after the u sub, and we get this. This times that, that's the area under the curve for any b. You give me b equals 3.9, 3.99, 3.999, 3.8, anything between 1 and 4, and this is going to give me the area from x equals 1 to x equals b. Then we say, okay, what happens to that number as b gets very, very close to 4 from the left? We had a 1 over 0 indeterminate form. We had to review some Calc 1 stuff to evaluate the limit. We got that was negative infinity, and a negative times a negative makes that positive infinity. So we write the integral as a limit, evaluate the proper integral using FTC, and the last thing we do is evaluate the limit which may require the use of some Calc 1 skills, like this one. If you have a non-zero constant over 0, you're going to get plus or minus infinity. To figure out which one, you need to analyze the sign of the numerator and the denominator as your a or your b approach this number from this side. All of that is important in determining that sign. Once you find the signs of all the factors, you know, positive over positive is positive, negative over negative is positive, positive over negative, or vice versa is negative. But if it's approaching 0 in the denominator, it's going to approach negative infinity. A positive number over something really tiny and negative is a very large in magnitude negative number. So that's it for this example. I'll do another example in another video.